We are Group 2, Science Content Area Literacy Strategies. Our group will answer these 4 questions. I will answer the question using the Wisconsin Department of Public Education's website and Chapter 5 of Content Matters. But first, here's what science literacy cannot be. The author of Content Matters state that most Americans remember their high school science experience as listening to lectures, reading chapters in a textbook, answering multiple choice questions, and having disconnected laboratory experiments and tests that focused on memory and not fact. So, what does science demand? It demands evidence, logical reasoning, explanations, predictions, avoiding bias, and knowing that science cannot completely answer all questions. It demands inquiry and having students engaged in questions, finding evidence to evaluate explanations, and students communicating their findings. Literacy in science demands the physical performance of these practices, not merely reading a textbook. Students do the cognitive work by engaging in the lesson. Students apply scientific reasoning by stating fact from experiments. Megan has great ideas for engaging students with popular TV shows. Here are some ideas for including reading and writing in science. For reading, students must read articles about science topics in the news and state evidence from their articles to back their arguments. Teresa has strategies to use while reading news articles. Students must define words in context instead of just reading the words force and mass. Students should learn through inquiry by doing observations, using their imagination, focusing on scientific questions, and gathering data together. Student scientists should compare outcomes of experiments and give explanations on the data. Writing. Students need to reflect on the big idea questions of the unit, write effective lab reports, make predictions before experiments, and state why they made the prediction. They need to write plans for experiments and think of what variables need to be displayed on their graphs. After collecting data, students can compare similarities and differences of their data with other students, while they can explain it to them too. In a nutshell, the students are in control of every step of the experiment, not the teacher. Speaking. Students will speak with each other by collaborating with classmates. They will communicate their understandings to others by analyzing their experiment. It is important to use accountable talk for purposeful and productive group discussion. For example, the teacher can ask, where can we find that information? In a literacy-rich environment, the answer could be found on a chart, a graph, or a direct quote from a reliable science source. This goes hand in hand with Teresa's reciprocal teaching that you will later hear. Assessments. Teachers can use informal assessment strategies such as listening to students' discussions, reading responses, quick writes, and teachers can use formal assessments such as written explanations and unit summary tests. This next information pertains to English language learners. With ELLs, the point of science is not to test their fluency. The best way to help them is to give examples. Use visual models so students can see what they're observing. Examples are graphs and diagrams. ELL students progress from seeing a model to making their own model and then using the language to describe that model. Christy has many examples of trade books that give visual picture examples of science topics. When writing, give examples of what writing should look like in a journal. Journaling should be informal and done frequently. Early in the year, have ELL students write in their own language and then restate the information in English. ELL students should engage in argument from evidence. This language-rich activity incorporates data and observations to back their argument. When students engage in conversation, that allows ELL students to hear many examples of the work they are expected to produce. And last, we have vocabulary, which is very difficult. Many words are Tier 3 words, such as tectonic plates, or everyday Tier 1 words that have different scientific meanings, such as cell and space. ELL students could not learn from dictionary definitions. Like I said before, words like force and energy have different meanings. Therefore, students should use technical terminology so ELL students learn through experience and application of a word. Most importantly, the culture of the class needs to be accepting of ELL students. Students should accept their contributions for their meanings and not focus on the informal language the speaker may use. Teachers should tell all students it's okay to say, "I do not understand what you said."